Hello everyone, and welcome to our video on where we are solving a handful of compound interest style problems. So whenever you see compound, so like compounded monthly, so that's our keyword. As soon as you see that, the method that I use is we're going to use the TVM solver function on our calculator. So the TVM solver function on our calculator, well, I'm using the free thing on the internet, but if you have 84 or Inspire, you could Google TV solver and then type in TI-84 or TI Inspire, and then there'll be videos that will help you figure it out. But this is very similar. It's almost done identically, but this again, it's ready to go on the internet. So you could try different ones out if you want. I like this one because this one also almost matches the TI-84 or 83 identically. Okay, and also it kind of tells you what's going on with these values. All right, so as soon as I have that, I get my calculator ready, so I'll be using this. And then let's read it. And then all I kind of do is just copy all of these blank to the left of the problem. Okay, so in this problem, let's go ahead. So I see compounded monthly, so I know let's get all of those. So I'm copying the same thing that was in that link. So PMT means payment. Future value is FV, and then the P over Y, and the C over Y. Okay, and these two numbers should be the same. All right, so let's start to fill these in. So it says find the present value if you would like $10,000 after 10 years if it is compounded monthly at 0.4%. All right, so it's saying find the present value. So that's what we will try to find. In just a little bit, I'm just marking it now. If you would like $10,000 after 10 years, so this is a future value, so it's after 10 years, so we'll plug in and say that this is 10,000. After 10 years, okay, so this will be the time, but time's not in here. Well, that will be handy in just a second. If it is compounded monthly, so monthly is 12 times per year, so that's the payment per year and the compounds per year are the same. And then we use this instantly again in our capital N, 12 times the time, which is 10. Okay, so this is instantly your compounds per year times your time every time. So that's what capital N is. Okay, and then it also said at 0.4%. Now on this we use the percent as given, so 0.4. So do not convert this. And then also, well, there's one last blank. This means payments. This means something that is done periodically, so every month or every week or whatever. And since it's not written anything about that in here, that makes this 0. Okay, so from here, then we'll enter it. All right, so I've got my solver ready. And we'll just go through and just make sure to calculate everything. So I've got 12 times 10, which is 120. We've got 0.4. And then present value, we'll just put 0 for now. It's just as a placeholder. Payment 0. Future value is 10,000. And then our payment per year is the same. And again, it converts it automatically. Okay, and then we're finding the present value, so we'll solve. Notice that this is negative. And notice when I click on it, it shows more. So that's the full answer. So you have to be careful of this calculator a little bit. Okay, so make sure to click on your answer when you are done with it. Notice it's negative. That's just the way that it's interpreted in our scenario. So that this means I would be putting this amount into an account. So that means I personally no longer have it. So like kind of I'm currently down this amount. But in 10 years, I will have this amount, the 10,000. Okay, anyway, so for our answer, we would write it as a positive. So we did find it. So the present value equals 9,607.96. And there it is. There it is. Done. It's done. So if we put all this money into an account, it's making about $400. Okay, so the interest rate isn't very great here. Okay, so that's kind of how it works when banks or whatever are giving you money. They don't give you much, right, after a long period of time, but they certainly will take money from you real fast, and we'll see that soon with what we'll see with their other interest rates. Okay, so we found it. That's it. Okay, so let's try out some others. So if you want to try these ones out on your own, so we got 3 here with the same thing. Oh, one side note, I guess. So if you are using TI-84, so it is the same menu, and I had links, and you could just Google it as well. But if you are using that, one thing, so the thing that you have to find, you press alpha, so there's a button alpha, and then you'd press enter on this actual 0 here on that calculator, and it will fill in the rest. Okay, so that's how you would do it if you are following along with an 84 and you have this menu pulled up. Okay, so but again, I'm just kind of assuming it's all fully online, and well, this would be available, or at least I hope it'd be available. All right, so let's break this down. So let's see these other ones. Okay, so in this example, it says find the interest rate for a deposit of $5,000 accumulating to $9,500, compounded weekly for 10 years. All right, so I see compounded. So that means I'm just going to go ahead and write my menu with all blanks. So I'm just copying the same thing that's in the calculator. All right, and then now let's start to fill these in. So it says find the interest rate. Okay, so now they're asking us to find that. For a deposit of $5,000 accumulating to $9,500. So this is a present value, and then this would be a future value. Now, on present value and future values, we usually do present values as negative, and then future values as positive. So they need to be opposite signs, and we'll show what happens if you don't do opposite signs. The calculator will say an error of some kind. Okay, so make these opposite. Okay, so we could add that note. PV and FV are opposite signs. And again, usually present value is the negative for the programming purposes. Okay, and then compounded weekly. So there's 52 weeks in a year, so we'll do 52 and 52. And then instantly, that's part of the capital N, 52. And then it says for 10 years, so times 10. Okay, so this is, there's everything. And you kind of mark it like we did here, too. So interest, well, we'll use capital I for interest rate in our calculator. Little r is sometimes used as interest rate as well. Okay, and then again, in this, there's no talk about payment, so we'll use 0 as a placeholder. Okay, and so now I'm back to my calculator. Okay, so we've got 52 times 10, and then we've got, for now, just 0. Here we've got negative 5,000, 0 payments. Future value is 9,500, and then these are 52 each. And then now we can go to the I%. Let's solve for it. And it gives us 6.42. And that's it. Okay, so this is how nice this calculator is. So we've got it. Maybe click on it in case they say to round it. Nope, that's it. So it is rounded to 2 decimals already. Okay, so hopefully that's all they need. And we got I is 6.42%. So and that would be an incredible interest rate. We would want to jump on that if some bank was giving that to us. Okay, so that's not really realistic in our case, but anyway, it's there. We got it. Okay, so back to this. If I did show that I accidentally put these both as positive, and let's change that back to 0 and solve. See, it just says it's red. Okay, so it's saying, hey, something's wrong. And the other calculators will say error of some kind because it's wanting us to say, hey, the present value should be negative, and then now we can get the real answer. Okay, or if you say this one's positive and then this one's negative, it will work out the same way. It gives you the same answer. Okay, so it's just saying make sure these are opposite. But again, it's usually best to make the present value negative because that carries over to other things. Okay, so anyway, so that's the ideal setup. Okay, so we found the interest. It's done. All right, let's see these other two. Okay, so in this one, we've got find the time required for a present value to double when deposited at 2% interest compounded semi-annually. So again, we see compounded. So let's go ahead and set up our calculator menu. So N equals I% equals PV equals PMT equals FV equals, and then our P over Y and our C over Y. So just getting it all ready. Okay, so it's saying find the time required. So we're trying to find T. Remember that your in is where the T is. So that means we will be solving for this. And for now, we'll just put a 0 as a placeholder for the in. So I'm pointing at the 0, but technically we're finding in. Okay, so find in, and we'll use 0 as a placeholder because we'll eventually use this equation to help us in this problem. So this one has a little bit of extra work. Okay, and then for a present value to double, so present value to double when deposited at 2%, so let's fill that in. So there's our capital I, 2% interest compounded semi-annually. So that means its compounds per year is 2. Okay, so that means I could fill those in, 2 and 2. Okay, so there's that, and then eventually we could say, hey, that would be 2, but again, we'll come back to that in a second. I'm just highlighting it for now. All right, there's no talk about payments, so I can put 0 here. All right, and then it just says, all right, well, it doesn't say what the amount of money is, so it doesn't matter what the amount of money is for it to double. It's still going to take the same amount of time. So if I put $100 in, or if I put $10,000 in, it will take the same amount of time to double. So that means they want us to just make up a number. I usually just use 100. So let's say if I put in 100, so we're going to let PV equal negative 100, and then we want it to double eventually, so that would mean FV is 200. Okay, so that should get the job done. So and you can play around with this. It won't matter what numbers you use for these for the correct answer. Okay, so let's go to the calculator, and then we'll just plug all those in. So I'm going to use 0 as a placeholder. That's what I want to find eventually. 2, we're using negative 100, and then payment is 0. Future value is 200, and then payment per year and compound per year are each 2. Okay, so it's all set up, and then now we need to solve for in. And we get 69.66. And just to show, let me make it like negative 1,000 and positive 2,000, because that's also doubling. Solve for in, still the same in. Okay, so and you could make it 0 just to verify. Yep. Okay, so just to show it doesn't matter. Okay, so one more time, same thing. Okay, so I think 100 though is a nice kind of round number. Okay, so we've got it. Okay, so we just found it. Okay, so we've found in. But that's not what the answer is. They said find the time. Well, that's where we go back to this equation. Let me box it in blue and say, hey, n equals this. So the C over Y times the T is 69.66. We have C over Y. It was 2, so that's why I highlighted it earlier. So it's 2 times T equals 69.66. And so now I can solve for T. So now we can divide by 2. And then we would get, okay, so T equals 69.66. I don't know that. I'm just going to use my calculator real quick. 34.83. Okay, so 34.83, and that would be in years. Okay, so it takes almost 35 years, and they might say round to the nearest year, but I'm going to assume they want it as decimals. So they might say that, however, I'm going to leave it as is. So it takes almost 35 years for this $100 to double to 200. Okay, and again, it didn't matter. We could have said 1,000 or 2,000 or 1,000,000 to 2,000,000. It takes that amount of time regardless. All right, so that's our answer for that one. So this is kind of the trickiest case, I think, because you have to do a little bit of extra work to get the actual answer. All right, and now let's see one other problem here. So find an effective. Not find. It just says an effective rate is called the annual percentage rate, an APR, or an annual percentage yield, APY. The effective rate converts a compounded rate into an annual rate. Find the APY, so or the effective rate or the APR, so they're all the same thing. So all of these are the same thing. Find the annual percentage yield corresponding to the following nominal rates of 3% compounded quarterly. So the nominal rate is saying that's your compounded rate. All right, well, I see the word compound, so I'm thinking let's go ahead and just set this up still. So PV, PMT, FV, P over Y equals C over Y equals, and then let's put in the one thing that they did give us. They said 3% compounded quarterly. Okay, so we've got 3% compounded quarterly right there. And then we could also put 4, and then we'll leave a blank because we know a time would go into that. Well, kind of similar to above, so sometimes they don't give you just flat out all the numbers, but we could just make them up, just like we did on this last one. All right, so let's figure out what we should use for this. All right, so again, I'm going to use if I'm making up numbers, I'm going to use my present value as negative 100. And what we will be doing is finding this. Okay, so so in these problems, so it's a unique problem, but this is what we will find. So we will find the future value. So we'll just put 0 there as a placeholder. There would be no payments occurring in this scenario. So we'll put 0 on here. And then here's the key for our time. Well, we're thinking we want to convert this to an annual rate. So we'll just use 1 for our time. Okay, so this is our kind of setup for everything. So I used 100. All right, so let's see what this does. All right, so now I can still go back to my calculator. We'll plug all those in. So we got 4, 3, negative 100 is fine. 0, let's use 0. And then we're converting that to 4. And then what we're saying is, well, let's solve for the future value. So if we solve for it, we get this. Okay, and then this will help us find our answer. So we found the future value is 103 point, I already forgot, 103.03. Now let me click on it, see if anything else pops up. No, so 103.03. And then this is why I used 100, because what we can see is, well, 100 increased to 103.03, and 100 is a nice number because we can instantly see the percent increase. It increased by that percent. Okay, so 100 increased by 3.03%. So I'm looking at, so I see the 100, I'm just looking at the ones place and onward, which means this is that APY, or it is the effective rate. Okay, so 3.03% is the effective rate. So that's it. So that's all it's asking for. So one reason that they do this, so I didn't have a problem on it, but one reason that they might do it is to compare, like, say, 3%. So this is, the effective rate is good for comparing So for instance, if they said 3% compounded quarterly, say versus like 2.9% compounded monthly. Okay, so they might do something like that. And then really it is just the whole setup still. So here, so might as well. So this is a little side problem. Okay, so a little side problem. So all I'm doing is a comparison. And we already did the compounded quarterly, so I just want to check out the 2.9%. We just want to see which is better, really. And so let's change those. So we've got, all I'm doing is changing that into 12, and then that would become 12 as well, because we're thinking 12 times 1, and then we're changing this to 2.9. And then now let's see the future value, and we can see, oh, it's $102.94. So this one didn't increase as much as the first one, so 102.94. So looking at the ones place and to the right, that is the percent increase. So 2. Ooh, it freaked out. So 2.94% would have been the effective rate for this one. Let's just say APY since I'm out of room. And so we can see, 3.03% is bigger than 2.94%. So this is the better option if we had those two choices. Okay, so that's kind of what it's used for anyway. So these were two cases here where we had to make up our own stuff. So sometimes we have to do that. Most of the time, though, it is like these first two, or even the ones from the previous video, where they give us all the information, and we just need to make sure we're plugging it into the right spots, and then solving for the right thing. Okay, so I hope all that helped. The TVM solver is a great one. Okay, so if you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.